Hi all, this is Alan with Bothell STEM Coach, and today we are continuing on with AP Physics 1, doing some circuit problems here. So I have a battery. As usual, I suggest you pause the video, try to do the problem on your own, and then come back after you've tried the problem. A battery with a voltage of 24 volts and an internal resistance of 1 ohm is connected to an external circuit as shown above. Determine the following. The equivalent resistance of the combination of the 4, 8, and 12 ohms. So this equivalent right here. So this is sometimes a little confusing because maybe you're used to seeing things in parallel. But one thing to note is the 4 and the 8 are in series. And the reason they're in series is that the current through them is the same. Okay, that's the important thing. Any current that comes through here has to go through this. So these two are now in series. So then I convert this to a 12. And then this becomes a 12. Now this 12 and this 12 are parallel because the two endpoints are the same. Okay? Like, if I had drawn it, some people find this confusing, so I want to emphasize this. Say I had it like this. Okay, this is 12 and 12. You see, wires just connect nodes together, and it's as though they're connected together here. So both endpoints of the resistors are the same, and so that makes them in parallel. So when I do 12 times 12 over 12 plus 12, which is how you could do two parallel resistors, you'll find that this is 6. So this is 6 ohms. The current in the 5 ohm resistor. Well, now in this circuit, what I've done is I have a 5 ohm, I have now a 6 ohm, and I have this 1 ohm. But now these are all in series. So to calculate the current through this 5 ohm is just to take the total current, total resistance, and do V equals IR. So V is equal to IR. The current is equal to V over R. The voltage is 24 volts. And the total resistance, because they're on series, is 12 ohms. That's equal to 2 amps. Okay. So that was A here. This is B here. C. The terminal voltage, VAC, of the battery. Oh, okay. So they want to know the voltage here and here. Okay. So that's like the voltage drop over the 11 ohm resistor, if you look at it from this picture. Because I just want to know what the drop over that 11 ohm resistance is. So I'll do C right here. To know that drop, since I already know the current, I know the current's 2 amps. I multiply by the resistance path of those two between these 2 points. Okay, so it's going to be V is equal to IR. It's equal to 2 amps times these two in series. So this is the effective battery. The voltage across here to here is 22 volts. Okay. The rate at which energy is dissipated in the 12 ohm resistor. Oh, okay. So the rate at which energy dissipated is just power. That's just a fancy way of saying power. Power is the rate of energy change. So I want to know how much power is flowing into here. Well, I know this is 22 volts. If I knew the voltage across here, like that would be useful. I do know that 2 amps is flowing here. So I know that by V equals IR, 10 volts, 5 ohms times 2 amps. This is a 10 volt drop. What that means is that if this is 0, again, I call this ground, for example. I call this 0 volts. And this is 22 volts up here. I have to drop 10 volts to make this 12 volts. So now the difference, the voltage across this 12 ohm resistor is 12 volts. 12 minus 0, because this guy's connected to 0 volts. So then I would say the power in the 12 ohm is equal to, I can use V squared over R because I know the voltage and the resistance. So that's 12 volts squared over the resistance, 12 ohms. That's equal to 12 watts. The magnitude of the potential difference at VBC. Oh, we already just computed that. We decided that was 12 volts. Right? And because we did that because we knew this was 22, and we subtracted 10 from 22 to get to 12 volts there. The power delivered by the battery to the external circuit. Okay, so the power delivered is the current times the voltage of the battery. And I already know that this battery is generating 2 amps. So the power of the battery is the 2 amps times 24. Actually, we want to do the external circuit, so I don't want to lose. I want to look at just the voltage, like across the terminals of the battery, not like the voltage source, but the terminal volts. And the reason I do that is if I look at just the voltage here, I'll be counting some of the battery that's being used by the battery, and I don't really want to do that. So I'm going to do 2 amps times 22 volts. So it's equal to 44 watts. And if you went through and calculated the power through everything here, like this power is what? Let's just do this. This one uses, we calculated 12 watts. This is also 12 ohms together, so they also burn 12 watts. This one, his voltage is 10, and his current is 2 amps, right? Sorry, it's 2 amps and 10 volts, so this guy using 20 watts. And so the power through each of the resistors is 20 plus 12 plus 12. It's 24 plus 20. That's 44 watts. Okay? So I hope you found that helpful. I'll see you in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.